Alright, at number 1, they're giving you the base and the height of the triangle, and you're just going to plug the base and the height into the formula. You can change 1/2 to a 0.5, and just do 0.5 times the base times the height that's given in your problem, and you should get 23.43 centimeters squared. And number 2, we're going to distribute, which is the same thing as multiplying the -8, the -9 and the +8, and then we'll end up combining like terms. So we're going to get a -36r, we're going to get a -63, +8 times +3r is a +24r, and +8 times +4 is a +32. As long as we're adding and subtracting, we're going to combine like terms. So your r's combine to be a -12r, and your two constant terms, those are numbers without variables, combine to be a -31. We're doing order of operations in number 3, and we have to follow our please excuse my dear Aunt Sally. We were actually doing that in number 2, but we had to multiply before we could add or subtract. Remember, this rule says do parentheses first, then exponents, then multiply and divide from left to right, add and subtract from left to right. So we have parentheses in this problem, but there's nothing to do inside the parentheses. I just have a number. So I'll go to the next order of operations, which is exponents, and I do have an exponent. So I'm going to bring down the 18 and the plus. I'm going to raise 5 to the second power, or the second exponent. That's 5 times 5, which is 25. And then I'll continue to go down my list. So I didn't have anything to do inside the parentheses. I did my exponents. The next thing that I do is I multiply and divide from left to right. Well, I do have one multiplication problem. It's in the middle of my problem. So I bring down my 18. I bring down my addition sign. 25 times 20 is 500. So I did my multiplying. There was no dividing. So then I add and subtract from left to right. So as I read the problem from left to right, first I get an addition problem. That's going to give me 518. And then if you're subtracting a negative number, that's always going to change to adding a positive number. Subtracting a -30 is the same as adding a +30. And then 518 plus 30, we're still adding here. We have no subtraction, so we'll add those up and we get 548. So again, following our order of operations there. We're starting to solve equations with number 4. We are solving for r. So when you're solving for a variable, that means you're trying to get the variable by itself. You're always going to add or subtract when you're solving. If there's a number that you can move from the side that your variable is by adding or subtracting, you want to add or subtract first when you're solving an equation. So my +4, that's adding 4, and the opposite of adding 4 is subtracting 4. So my 4's will cancel on the left-hand side. I have 4 times r left, and 20 minus 4 is 16. Again, I'm solving for r. I still don't have r by itself, so look at what's going on with the r. It's 4 times r. So if I'm multiplying r by 4, then to get rid of multiplying by 4, I'm going to divide by 4. 4's will cancel because 4 divided by 4 is an understood 1, and 1 times r is r. 16 divided by 4 is 4. If you'd like to check an answer when you're solving an equation, you can just go back and plug that answer back in. So if you're taking your final exam and you're not sure about your answer, you could just plug it back in. 4 times r plus 4 has to be equal to 20. R is 4, so that's 4 times 4 plus 4. According to order of operations, we have to multiply before we can add. So that gives me 16 plus 4 equals 20. 16 plus 4 would give me 20. 20 does equal 20. And again, you don't always have to check. That's when you solve equations. It's fairly simple to check. So I would suggest that you do so if you're concerned that your answer is not correct. In number 5, we're solving for x, and x is being multiplied by 9 over 10. So anytime your variable is being multiplied by a fraction, you can just multiply by the reciprocal of that fraction. So we're going to multiply both sides of the equation by 10 over 9. So the 10's cancel and the 9's cancel. We're solving for x, and we get x on the left-hand side. You can use your calculator if you want to do 27 times 10 over 9. You can do a little cross-canceling. This is how I learned to multiply fractions. 9 will go into 27 3 times, and 3 times 10 is 30. However you get 30, that's all that matters. And again, if you wanted to plug it back in, you plug it back into the equation and do 9/10 times 30, and you should get 27. If you don't get 27, that means your answer is not correct. We're solving in number 6, and the first thing that I notice is if I'm solving for b, and I have 2 b's on the left-hand side. So that means I can simplify the left-hand side. So I'm going to combine my like terms. That's going to give me a negative 2b plus 9 is equal to, and I'm just repeating the right-hand side. Now I notice that I'm solving for b, and there's a b on the left, and there's a b on the right. That's not a good thing. You need your variables to be on the same side of the equation. So what I usually do next is I decide which variable is the smallest, negative 2b or negative 3b. Negative 3b is smaller than negative 2b since it's a negative. So I'm going to move the negative 3b. The whole entire term, I'm going to move it. So since it's negative, you're going to move the whole entire term by adding. Since the term is negative, you'll move the whole entire term by adding. On the left-hand side, you get negative 2b plus 3b. That's going to give you a positive b. You're going to bring down plus 9. You're going to bring down equals. Your negative 3b and your positive 3b are going to cancel, and then you'll be left with 14 on the right-hand side. Again, you're solving for b. Now things look a little bit better. You only have one b, and it's on the left-hand side. So to solve for b, you've got to get rid of adding 9, and the opposite of adding 9 is subtracting 9. So you'll subtract 9 from both sides. 9's will cancel. You'll be solve for b. b is equal to 14 minus 9, which is 5. And again, if you want to go back, plug it into the original problem, you would have to plug it into all the b's on the left and the right-hand side. And to make sure it is a solution, both sides would have to be equal to each other. And number 7, we're solving for n. n is on the left-hand side. The good thing is I don't have more than one n. So I look on the left-hand side. I have to get rid of multiplying by 5. And I also have to get rid of subtracting by 9. Again, your first step should be, most of the time, adding or subtracting, unless something crazy is going on in the equation. So I'm subtracting that 9. So I want to move it first by adding 9. That's going to leave me with 5 times n is equal to 26 plus 9, which is 35. Still solving for n. n is being multiplied by 5. So we're going to divide both sides by 5. And n is going to come out to be 7. In number 8, we're still solving. The first thing that I notice is I have a b on the left and a b on the right. That's not a good thing. I need to get those b's together on the same side, so I check to see which one is the smallest. Negative 9b is smaller than negative 5b, so I'm going to add, since 9b is negative, I'm adding 9b to both sides. And the reason I always go with moving the smaller one is I'm trying to create a positive number in front of my variable. And this just helps me not make mistakes. Anytime we have negatives, it kind of causes us to make a mistake. So now I have a negative 5b plus 9b. That's going to give me a positive 4b. And what's good now is I have one b, and that b's on the right-hand side. So you're going to look at the right-hand side of your equation. You've got to move the minus 1. And you also have to move the 4 times your b. So again, if we can move something by adding or subtracting, we want to do that first. So that negative 1, we can move it by adding 1. That's the opposite operation, and it will cancel it out. That leaves us with 6 is equal to 4 times b. Again, we're solving for b. B's being multiplied by 4. So the opposite of multiplying by 4 is dividing by 4. You can reduce 6/4 if you want to. If you're going to leave it as a fraction, it needs to be reduced. So you could get 3/2. And also another acceptable answer would be 1 1/2. And also another acceptable answer would be 1.5. In number 9, we're solving for x, and what I notice is I have two x's on the same side. So if I have two x's on the same side, that means I need to combine those two x's together. If they're both on the same side of the equation, they're like terms, and I need to combine them. Well, in the 4th grade, I learned that you couldn't add or subtract fractions unless you had a common denominator. So I don't have a common denominator here, but I can rewrite both of these fractions as some number over 15. Or if you have a scientific calculator, you could do 2/5 minus 1/3 in your scientific calculator. I'm going to do it the old-fashioned way. 5 goes into 5 times 3 is 15, so you have to multiply the 2 by 3 also, so that gives me 6/15. And then for the 1/3, I say 3 times 5 gives me 15, so 5 times 1 gives me 5. Now I can subtract my two fractions because I have a common denominator of 15. So I subtract the numerators only. 6 minus 5 is 1. So I have 1 over my common denominator of 15. So now I have 1 over 15 times x is equal to 5. Again, if you have a fraction that's being multiplied times your variable, to get rid of that fraction, you're going to multiply both sides by the reciprocal of the fraction. The 15 and the 1's cancel, and you're left with 5 over 1 times 15 over 1, and that is 75. If you want to check your answer, you can by plugging 75 into both of your x's in your original problem and simplifying the left to make sure it equals the right-hand side, which is 5. In number 10, we have an equation that has more than one variable, and they're telling me that I'm going to need to solve for h. Alright, so the first thing that I probably want to do is I have to get rid of 1/2 and I have to get rid of b. I would probably get rid of the 1/2 first. So if I have a fraction that's being multiplied times my variable, then I'm going to multiply by the reciprocal of that fraction. So I'm going to multiply both sides by 2 over 1. On the left-hand side, I have 2 over 1 times a, and that's just 2a. On the right-hand side, the 1 over 2 times the 2 over 1 cancel each other out, and then I'm left with b times h. And again, just as a reminder, we're solving for h. We haven't solved for h yet because it's been multiplied times b, so we're going to divide both sides by b, and then I have h solved for. So h is equal to 2 times a divided by b. In number 11, we have an equation again that has more than one variable, and they're asking us to solve for y. So what's a little bit unusual about this problem is you're not going to add or subtract first, and that's because everything on the right-hand side is being divided by 8. So what we have to do first in this problem is a little bit different, and that's because of the 8. Since everything is being divided by 8, then we want to move that 8 first, or we want to get rid of dividing by 8. So we're going to multiply both sides by 8. On the left-hand side, I have 8 times x, which is 8x. And on the right-hand side, the 8's will cancel because multiplying by 8 and dividing by 8 are opposite operations. And then I'm left with w plus y plus z. And again, they're asking me to solve for y. So to get y by itself, I have to move the w, and that is a positive w, so I would move it by subtracting. And I have to move the z, and the z is also a positive z, so I'm going to move that positive z by subtracting. So I'm actually going to subtract w, and I'm going to subtract z from the right-hand side. If you subtract w and z from the right-hand side, remember, you have to do the same thing on the left-hand side. So I'm going to subtract w, and I'm going to subtract z on the left-hand side. 8x, w, and z are not like terms, so I cannot combine those. So I'm just going to have to write 8x minus w minus z is equal to, and on the right hand side, w minus w will cancel, z minus z will cancel, and I've actually solved for y. So y is going to be equal to 8x minus w minus z. In number 12, we're solving for s. S is on the right hand side of the equation. And to solve for s, I have to get rid of adding r. So the opposite of adding r is subtracting r. So if I subtract r from the right, I have to subtract r from the left. And a, b, and r are all unlike terms. So all I can do here is just bring down a plus b and then minus the r. On the right hand side, the r's cancel and you're left with s. So you have solved the equation for s. Number 13, we're working with some percentages here. It says what is 5% of 600. So you could kind of think of this like a sale price. If you are purchasing something for $600 and it's 5% off, we would just take the 600. We would multiply it times the decimal for 5%. Remember, when you remove the percent sign, you take the decimal and move it 2 places to the left. So if I do that, I get 0.05. And when I multiply 600 times 0.05, I get 30. So when it says, what is 5% of 600? Okay, and again, I just made up the fact that this might be a sale price, but we're just actually finding 5% of 600. So 5% of 600 is just the 30. If it was a sale price problem, then I would subtract the 30 from the 600, but it's just asking me to find 5% of 600. So that answer is 30. 14 is a little bit harder because it says 50% of what number is 64. You could do it a couple different ways. Some of y'all might just be able to reason this one out since it's 50%. 50% is half. So it says half of what number is 64. So you would be thinking of what number could I take half of or divide by 2 to give you 64. And that would be the same thing as doing 64 times 2. So you might be able to reason this one out and realize the answer is 128. Some of you may have worked it out using a little equation, is over of equals percent over 100. And then our is number is our 64. So it says is over of. Our of is what we're looking for. We don't know that, so that would be our variable. Equals our percent, which is 50. You just actually remove the percent sign and put it over 100. You don't have to move the decimal if you're going to use this formula because you have the out of 100 and you just put the 50 there. And then you would cross multiply and you would get 50 times x is equal to 64 times 100, which is 6400. And then you would divide both sides by 50 and you would get x is equal to 128. Either one of these works. Again, I think because it's 50%, you might be able to reason it out. If it wasn't 50%, then you might have to do the equation is over of equals percent over 100. 95 says 920 is what percent of 1,559. Again, I can't reason this one out, so I'm going to use the little formula. Is over of equals percent over 100. We don't know our is number. Or excuse me, yes we do. 920 is, okay, so we know our is 920. Of 1559, we know our of number is 1,559. And what we're looking for is we're looking for what percent. So our variable goes in for the percent. And then that formula says percent over 100. We're going to cross multiply. We're going to get 1,559 times x equals 920 times 100. And then if we're solving for x, since it's being multiplied by 1,559, we've got to divide both sides by 1,559. And that should give us, I have rounded here, and that's why I have the little squiggly lines. I've rounded to the nearest whole number percent, and that's 59%. 16 says, Andy left a 15% tip for a meal that cost $30. What was the cost of the meal, including the tip? So you want to take the $30. You actually want to calculate the tip. I noticed the other day I was eating at Red Robin, and they had a tip calculator right there on the table. It's the first time I had seen that. So it was actually trying to help you out, figure out what tip you should pay. So 30 times 0.15 is $4.50. And of course tips are something that we pay to our waiter or our waitress. So we would actually add the $4.50 to the $30. And so that would give us $34.50. That would be our meal and our tip. The next set of directions say solve using the addition and the multiplication principles. Just kind of, it really just means solve. Addition and multiplication principles, they're the same rules. If we're solving an inequality, we solve that just like an equation. The only thing that we have to be concerned about is if we ever multiply or divide by a negative number, the inequality sign has to flip, has to change. So we're going to work these just like equations. So when I look at 17, I notice I have a z on the left and I have a z on the right. That's not a good thing, so I need to get my z's together and I ask myself which z is the smallest. And my answer would be 4z, so I'm going to move the 4z. It is a positive 4z, so I'm going to move it by subtracting. That's going to leave me with 8 is greater than or equal to 5z minus 4z, which gives me an understood 1z. And then I bring down the plus 11. Now, I only have 1z. That's kind of what I was trying to do there. And that 1z is on the right-hand side. So I need to solve for that 1z, and I'm adding 11 to that 1z. So I want to undo the adding 11, and I want to subtract 11 from both sides. 8 minus 11 is negative 3. And plus 11 and minus 11 will cancel. One thing I always like to tell my students is if I have an inequality, it really helps if the variable is written on the left-hand side. So I'm going to put the z on the left-hand side. I'm just going to make sure that I don't change the sign or the meaning of the problem. So if you'll notice, the little end of the sign is pointing towards your variable. So if you put the variable on the left-hand side, that's okay, as long as that same end of the sign is pointing towards your variable. So make sure the little end is still pointing towards the z. And then this says z is less than or equal to negative 3. Now you didn't have to graph here, but I just kind of want to talk about graphing. Your negative 3 would be in the middle of your graph. And we're graphing all the numbers that are less than or equal to negative 3. All the numbers that are less than or equal to negative 3. Since there is an equal to on our less than sign, that means our circle is closed. And then we would shade all the numbers that are less than negative 3. Those would be the numbers on the left-hand side of negative 3. You would also include the arrow because you want to include all the numbers that are less than negative 3. And that arrow to the left actually takes you all the way to negative infinity. Again, you didn't have to graph these, but I just wanted to kind of show you some extra problems as far as graphing. So in number 18, we're solving for x. X is all by itself, or no, it's not, but it is the only variable in the problem, and it's on the left-hand side. So I have to get rid of adding 4, and I have to get rid of multiplying by 3. So again, if we can add or subtract in our first step when we're solving an equation or an inequality, that's what we want to do first. So we're going to subtract 4. That leaves us with 3 times x is less than 28 minus 4, which is 24. Again, we're still solving for x. X is being multiplied by 3, so we're going to divide both sides by 3. And again, the only thing that's different about solving an inequality versus solving an equation is if you ever multiply or divide by a negative number, you need to flip your inequality sign here. So I'm dividing by a positive 3, so my sign would not flip. 24 divided by 3 would give me 8. And if you were graphing, you would put the 8 on the number line. Your circle would be open because it's just less than 8, not less than or equal to 8. And since it's less than, we're shading all the numbers to the left. If it were greater than, we would shade all the numbers to the right. They are asking you to solve and graph at number 19. So we're solving for A. I only have one A. That's a good thing. It's on the left-hand side. It says A minus 7. So I want to get rid of subtracting 7. So I would do the opposite operation, and I would add 7. That's going to give me A is less than negative 12 plus 7, which is a negative 5. Take your negative 5, place it on your number line. There is no equal sign here, so my circle would be open, and I'm graphing all the numbers that are less than negative 5. So that would be all the numbers to the left. Again, less than is to the left, greater than is to the right. In number 20, the directions say find the x and the y intercepts, then graph your equation. So remember, when we're finding the x-intercept, we let the y value go to 0. Because if you're an x-intercept, you're pointing on the x-axis, and that means your y value is 0. So when we let y go to 0, remember that just takes the y term completely out of the problem. And that leaves us with negative 3x is equal to 15. And then we're going to solve for x. Since x is being multiplied by negative 3, we're going to divide both sides by negative 3. And we're going to get an x-intercept of negative 5. So that means we're going to place a point on the x-axis. That's the axis that goes left and right, to the left 5. Then we're going to find our y-intercept. When we find our y-intercept, that's where the graph crosses the y-axis. We let our x value go to 0, because any point on the y-axis has an x value of 0. That means if x goes to 0, that knocks out the whole negative 3x term. So that leaves me with negative 15y is equal to 15. And I am solving for y. And y is being multiplied by negative 15. So I'm going to divide both sides by negative 15. And my y value comes out to be negative 1. So my graph is going to cross the y-axis at negative 1. The y-axis is the axis that goes up and down. And if my y value is negative, I'm going to go down 1. And then I am going to draw my line. I only need 2 points to draw a line. You can have more if you want to. But if you're finding the two intercepts, you'll only have 2 points. If we have slope, we can create more than 2 points. But if you're graphing using the intercepts, you'll just have those 2 points, one on the x-axis and one on the y-axis. Number 21 is asking us to graph x equals 1. It's kind of a fairly simple equation, but it can cause us some difficulties. So if you're graphing a line where all the x values are 1, there's a couple different ways that you can look at this. This means no matter what the y values are, the x values are always 1. So if you wanted to make a little t-chart, you can. So all the x's are 1, and the y's can be anything. But the x's have to be 1. That's what the equation says. X is equal to 1. So some of y'all may have this graph memorized. If you don't, making a t-chart may be helpful. So then I'm going to graph the point to the right 1 and down 1, to the right 1 and 0, to the right 1 and up 1. And if you'll notice, that creates a vertical line. Anytime your equation just has an x in it, your line will be vertical. Anytime your equation just has a y in it, your line will be horizontal. Number 22 is asking us to write an equation for this specific graph. So if you'll notice, the line is vertical. So anytime the line is vertical, that means all the points have the same x value. So if you'll just kind of pick out a few points, if you'll notice, each one of those points have the same x value. So this point right here would have an ordered pair of -4. 1, 2, 3, -4, +4. This ordered pair would have a point of -4, +2. This ordered pair would have a point of -4, 0. So if you'll notice, all the x's are the same. That's what happens when you have a vertical line. So your equation would be x is equal to -4. Again, the y's can be anything, but the x's have to be -4. That's what creates a vertical line. Vertical lines have x equals, and horizontal lines have y equals. Okay? They don't have an x and a y in their equation. That's what makes them vertical lines. That's what makes them horizontal lines. So maybe we should write that down. If you have x equals a number, that's going to give you a vertical line up and down. If you have y equals a number, that's going to give you a horizontal line. So if x is the only variable in your equation, your line will always be vertical. If y is the only variable in your equation, your line will always be horizontal. Number 23 says find the slope in the y-intercept. When it's asking you to find the slope in the y-intercept, it's really asking you to put the equation in the form of y equals mx plus b. So in other words, solve the equation for y. When the equation is solved for y, the m value, that's the number in front of your x, is the slope, and the b value is the y-intercept. So we're going to use our skills where we had more than one variable in some prior problems, and we're going to solve for one variable, and we're going to solve for y. Y equals mx plus b is a very common form of a linear equation. That helps us find the slope in the y-intercept, which helps us graph. So if we're solving for y, we have to move the 2x term first. And since that 2x term is positive, we're going to move it by subtracting. And we're going to get 5y is equal to, and since I'm trying to put it in this form, y equals mx plus b, I'm going to write the negative 2x term first, just because that's the way the form of the equation is written. So I have a negative 2x and I have a positive 15. Still trying to solve for y. So y is being multiplied times 5. So I want to divide everything by 5. I want to divide everything by 5. So that's going to give me y is equal to negative 2/5 x plus 15 divided by 5, which is 3. So that puts my equation in slope-intercept form. It is solved for y. So that means that my slope is the number in front of my x. So my slope would be negative 2/5. And my y-intercept, where the line crosses the y-axis, would be this number that doesn't have an x with it. That's called a constant number. And my y-intercept would be 3. In number 24, they're asking me to find the slope of the line going through the pair of points. So I do have a slope formula. Anytime I'm given two ordered pairs, I can do y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. So just remember, your two ordered pairs represent x's and y's. So we can think of that first ordered pair as your x sub 1 or your first x, and your y sub 1 or your first y. And then the second ordered pair, the 6 is your second x, and your 2 is your second y, or your y sub 2. And then we just follow the formula. Second y is 2, minus first y is 5, divided by second x, which is 6, minus first x, which is negative 5. 2 minus 5 is negative 3. 6 minus a negative 5. Anytime we're subtracting a negative, that's really adding a positive. So I have a negative 3 on the top, and I have 6 plus 5, which is 11 on the bottom. Anytime your slope has one negative, it's going to stay a negative slope. If it has two negatives, a negative divided by a negative, then it's going to change to a positive slope. So since I have one negative, my slope stays negative. This is also something that you might want to know. If you end up with a 0 in the top of your slope, let's just make something up like 0 divided by 5. 0 divided by 5 would simplify to be 0. And then if you had the 0 on the bottom, 5 divided by 0, you can't divide any number by 0, and we call that undefined. So later on, when you're in other math classes, that information may be helpful. In number 25, it says graph using the slope and the y-intercept. So the good thing about 25 is it's already in y equals mx plus b form. Already solved for y. So I know that the slope of my line is positive 1/4, and I know that the y-intercept is negative 2. The slope is the number or the coefficient in front of the x once the equation is solved for y, and the y-intercept is your constant term. That's the term without a variable. So we always graph the y-intercept first. It's a negative 2, so I'm going to go down 2 units on the y-axis. And my slope is positive 1/4. Anytime your slope is positive, then your line is going to rise from left to right. Anytime your slope is negative, then your line is going to fall from left to right. So our slope is positive. So from the y-intercept, we're going to rise 1 and go to the right 4. And we can make several points if we want to. From that point, we can rise 1 again and go to the right 4. That would create our line that is rising. Again, if the slope is positive, the line is going to rise from left to right. If the slope is negative, it's going to fall from left to right.